This section starts out with a general overview of batteries. Batteries, when you have a galvanic cell or a bunch of galvanic cells linked up together. If you do have a bunch in series linked up together, you're going to add your voltages together to get your total EMF. Your cathode is your positive, your anode is your negative. The EMF is determined by what the substances are that you have in your battery, and how long your battery works depends on how much of the substances you have. Now the rest of this section is over the different types of batteries. This is not that important. What you may want to do is just skim it, either in your notes or in your book, get a general idea of what's going on with these different types, and then move on. It's not anything you really need to learn or memorize here. The one that's probably that shows up the most often is the lead-acid battery, where you have an anode reaction, an oxidation reaction happening with lead, a cathode reduction reaction happening with lead as well, and then you also have an acid that is changing its oxidation state as well. It's usually sulfuric acid. And the neat thing about lead-acid batteries is you can recharge them using an alternator. I don't know what that says, but an alternator to reverse the direction of your cell reaction, which will regenerate your lead and your lead oxide. And we're going to talk about that, but pretty much you're going to see these in car batteries. So I am going to skip a little bit. Like I said, you may just kind of want to look these over, just in case they throw these in on one of those weird multiple choice questions. But we're going to skip on ahead to corrosion. Corrosion happens whenever a metal gets oxidized. Mostly this is a spontaneous reaction, although there are things you can do to make it happen a lot faster or slower. A lot of times also you'll get a thin coating of the metal oxide on the outside that will protect it from further oxidation, and so this actually can be a good thing. Now the corrosion of iron is a really important corrosion reaction that you definitely need to be aware of. It is a redox reaction, and so we're going to look at it like a redox reaction. You have part of your iron that's acting as an anode, in which the iron is being oxidized. You also have a cathode region, and where you have the reaction of the iron with oxygen, and you have this kind of reaction occurring. So looking at this equation, you can see you have to have oxygen and you have to have water in order for iron to oxidize, but you can also put other things in there like salt, and that will act as a catalyst and make it happen a lot faster. So let's say we have a big piece of iron and some water falls on the iron. That's a water droplet. Now we also have some oxygen interacting here. Now what's going to happen is part of the iron starts to act like an anode, and part of the iron starts to act like a cathode. So let's say that this part right here is the part that acts like an anode. That's where the iron starts to turn into iron 2 ions. And the iron 2 ions can be turned into rust. Now we know the electrons go from anode to cathode, so electrons will travel from one part of the iron to another part of the iron. That's where the cathode is, right over there. And over here, our oxygen is getting reduced using this equation here. You'll end up with rust happening right around here between your anode and cathode, because you have the transfer of ions going from going this direction. Over here, your iron ions changing into iron 3 ions, which will later form rust. Now you toss some salt into that water, then that's going to cause the transfer of ions to happen really quickly. It's going to cause our transfer of electrons to happen really quickly, and our iron will oxidize even faster, which is why it's important whenever you drive a car when you drive a car through roads that have been salted, that you wash your car off to get all that salt off, because the salt causes your car to oxidize a lot faster than just regular water does. So like we said, we have to have water to have corrosion of iron, and the presence of a salt will make the corrosion happen a lot faster. Now there are several different ways that you can prevent corrosion. You can prevent corrosion by coating the metal by cutting the metal with some other metal that oxidizes pretty easily, and that will protect the metal. You can prevent corrosion by something called galvanizing. by placing a very easily oxidized metal on top of the metal we're trying to protect. So we put zinc over iron. The zinc oxidizes, forming a protective layer over the iron. You can alloy. If you add a few metals to this, you can change the iron's reduction potential, and that will reduce it, make it less likely to be reduced. You can also do something called cathodic protection, where you connect easily oxidized metals, some sort of anode, to a less easily oxidized metal, and it keeps the less easily oxidized metal from experiencing corrosion. The problem is you have to replace that whenever it starts to wear out.